What's up, everybody? This is Danny Mathematics again. Today, we're going to focus on a high school mathematical concept called factoring fourth degree polynomials, okay? If you're a sophomore or a junior or even a senior in high school, you're probably doing problems like this, okay? So once again, we're going to talk about factoring fourth degree polynomials, okay? If you watch my videos about the quadratic formula, it's basically the same thing. We're just trying to find out what values of x can we have that we can plug in to make this whole thing equal 0, okay? There are only up to 4 possible values because the highest degree is to the 4th degree, meaning that there are only 4 possible values x could be in order to make all of this equal 0, okay? Now, what we're gonna do is we're gonna figure out what are those possible values, okay? Now, the only way or the only set of values that can be possible values are numbers that are a factor of 48, okay? So, step 1 is you want to figure out what value is the constant within the 4th degree polynomial. The constant is the number that is not attached to an x or to a variable, okay? It's just by itself, okay? So that is the number that we want to focus on. We want to focus on that number, okay? So now we're going to list the factors of that number. And a factor is just a number that can either multiply or divide into this number perfectly, okay? So I'm going to list down the numbers that we can use, okay? 1 can divide or multiply into 48. 2, 3, 4, 6, 8, 12, 24, and 48, okay? And then there is one more value that we're gonna talk about, but I'm gonna talk about that in a second, okay? But here's how you know these are factors, right? Well, if we multiply 1 and 48, it will equal 48, right? If we multiply 2 and 24, it will equal 48, okay? 3 and I forgot one of the factors. I should have put 16 right here. 16 is another factor. 3 times 16 equals 48. 4 times 12 equals 48. And of course, 6 times 8 equals 48. So those are possible values of x that we can use to figure out if they are the values that can make all of this equal to 0, okay? Also, let's also look at the coefficient of the highest degree. The coefficient of the highest degree, in this particular case, is 2. So what we have to do is we have to divide by 2, right, to see what other values can come out, okay? Of course, if we divide 1 by 2, that will be 1/2. Okay? If we divide 2 by 2, it will be 1. We already got 1. And if we divide 3 by 2, it will be 3/2. But I don't have to keep going because I already know that if I did 48 divided by 2, it'll equal 24. If I did 4 divided by 2, it'll equal 2. If I did 6 divided by 2, it'll equal 3. So all the other values, if I divide by 2, we already have those values, okay? But of course, if I divided 1 by 2, I would have 1/2. And if I divided 3 by 2, I would have 3/2, okay? So these are all of the possible values that we can plug in as x, okay? But once again, only up to 4 of them are actually going to work when it comes to figuring out what are the solutions of this particular 4th degree polynomial, okay? So the next part is we're good. That was step 1. The next part that I want to do is I want to write out the parent function of this 4th degree polynomial, okay? So once again, a 4th degree polynomial is this. A times x to the 4th power, and once again, the letters only represent the coefficient values that you see, okay? I'm just writing it out as the parent function. A x to the 4th power plus bx to the 3rd power plus cx to the 2nd power plus dx to the 1st power. If it's to the 1st power, we don't have to write a 1, all right? Plus e, and e is the constant or the number that is not attached to an x, okay? That's how the parent function of a fourth degree polynomial should look. And what I'm going to do is I'm going to highlight each coefficient and the constant its own color. Okay, because there's a major reason why I'm doing this, okay? Because you already know we're going to identify the values of these particular letters, okay? Representations. So D, I'm gonna make that be green, and E, I'm gonna make that be a dark blue, okay? Now, let's just look. From this particular polynomial, right, fourth degree polynomial, we can identify what numbers are represented by the letters, okay? So let's look. A to x to the fourth power. In this particular case, that's 2. So A is 2. Okay? Plus B, x to the third power. In this case, it's 7x to the third power, so 7 must be B. Okay? Plus cx to the second power, in this case, is 29x to the second power, so 29 is the C. Or actually, it's a negative 29, right? You have to always associate the sign that's in front of the value or the coefficient, okay? D, okay? D is this D times x or dx. Right here is negative 112x, so D will be negative 112. And then, of course, we have E, which E is the constant of the number that is not attached to an x. And in this case, it will be a negative 48. Okay, a negative 48. Okay, so we have our values. So now what we're about to do is we're about to actually start the next important step, which is synthetic division. Okay, we're going to use synthetic division to find out 2 of the possible values, okay? We're going to use it to find out 2 of the possible values. It's going to be 4 values, but we're going to go down to 2, and then the last 2, we're going to use the quadratic formula, okay? Because there's different ways that you can do this. So now, what you need to do is, since we have all the values, right, of a fourth degree polynomial, what we're going to do is we're going to draw a division sign, okay? We're going to draw a division sign, and all we're going to do is just plug in these values, right, in the division sign. So I got the 2, okay, I got 7, I got negative 29, I got negative 112, and I got negative 48. So remember, guys, in order for one of these possible values to work, at the end, it has to equal 0, okay? So once I get to negative 48, whatever I'm adding or subtracting from negative 48, it has to equal 0. If it does not equal 0, then it does not work, okay? So let's just try a random number, and I'm just gonna try a number that I know that does not work, so I can just show you what I'm talking about, okay? So let's try 1. Say out of this set, I wanted to do 1. So I'm gonna try out 1, okay? I'm gonna try out 1 to see if that possible value is gonna work, okay? So all you do is just bring down this 2, and all you're gonna do is multiply 1 by whatever number is down here, okay? So 1 times 2 is 2. 7 plus 2 is 9. 1 times 9 is 9. Okay, negative 29 plus a positive 9 is a negative 20. 1 times negative 20 is negative 20. Negative 112 plus a negative 20 is a negative 132. And then 1 times negative 132 is negative 132. And you know, if I added these two negatives together, they will not, whatever the answer is not going to equal 0. Okay, so I know for a fact, guys, that it's not 1, okay? So, of course, you continue to do it until you figure out which ones that actually work, and I'm just gonna go to the ones that actually work because I already have my notes, okay? So let's try negative 4. Say I tried 1, it didn't work. I tried negative 1, it didn't work. I tried 2, I tried 3, so I finally got to 4. So I'm gonna do negative 4. Let's try that, okay? So we have negative 4. So I have negative 4 times 2 is a negative 8. okay? 7 plus a negative 8, or you could just say 7 minus 8 is a negative 1, okay? Negative 4 times a negative 1 is a positive 4, okay? Negative 29 plus a positive 4 is a negative 25, okay? Negative 4 times a negative 25 is a positive 100, okay? Negative 112 plus a positive 100 equals a negative 12, okay? And then a negative 4 times a negative 12 is a positive 48, okay? A negative 48 and a positive 48 cancels out to 0, right? So because it cancels out to 0, we automatically know that x equals negative 4 is one of the possible values that we can plug in to make this whole thing equal 0, okay? So that's one step. Now, as you notice, we have less numbers, okay? This goes away, we're good. We have less numbers. So now what we're gonna do is we're just gonna plug in these numbers and do the whole synthetic division again, okay? So if I just bring these numbers down, and once again, it's the same thing, they gotta equal 0 at the end. So those same numbers, I'm bringing them down. I have 2, negative 1, negative 25, and negative 12, okay? Now, once again, if you already tried some numbers and it didn't work, you don't have to try them again, okay? So I don't have to try number 1, number 2, and number 3 again because I already know that those didn't work the first time, it's not gonna work the second time. So I say, okay, cool, I tried negative 4, why not try positive 4 to see what is gonna happen? So we're gonna divide everything by positive 4, we'll do the synthetic division, right? Which we're really multiplying and adding, really. So I'm gonna bring this 2 down. And remember, everything that comes down, you multiply by 4. So 4 times 2 is 8. Negative 1 plus a positive 8 is 7. 4 times 7 is 28, a positive 28. A negative 25 plus a positive 28, or you can flip it and say 28 minus 25 is a positive 3. Right? 4 times 3 is a positive 12. Negative 12 and positive 12 put together cancels out to 0. So I know that x equals 4 is another possible answer, a possible solution. Okay? So already we have 2 solutions, okay? Now, what we can do is we can continue to do the synthetic division, but as we realize, the numbers are smaller. So we actually went down from 1st degree to 3rd degree. Now we're down to 2nd degree, okay? So there's 2, 7, and 3. I'm gonna write it as a 2nd degree polynomial, okay? Because now we can go from synthetic division. You can continue to do synthetic division if you want. It's no problem, right? But if you get to the 2nd degree part, then you can actually switch over to quadratic formula. And I know a lot of people know how to use the quadratic formula, right? So of course, a quadratic or a 2nd degree, which is quadratic, right, comes in the form of ax squared plus bx plus c, okay? Ax squared plus bx plus c, okay? And all I'm doing is these numbers, right? I'm just gonna plug these numbers as A, B, and C, okay? So once again, we had 2 is A, right? 2 is the A, 7 is the B, and then 3 is the C, okay? So let's do that over here. I got 2 x squared plus 7x plus 3. Okay, so now we have a 2nd degree polynomial where we can actually utilize the quadratic formula. Once again, You can continue to do synthetic division if that's what you want to do. Or once you get to the second degree form, you can just switch to quadratic formula. I'd rather switch to quadratic formula because once we do the formula, then we will find the last two possible solutions at the same time, okay? So once again, you already know quadratic. As you see A is 2, B is 7, and then C is 3. As you can see, we already have our values. So all we're gonna do is just plug in into the quadratic formula. Here's the formula. Once again, if you do not know the quadratic formula by heart, just type it in on Google, on your computer, on your smartphone, and the formula will appear, okay? So it's negative B plus or minus the square root of positive B squared minus 4 times A times C, all divided by 2 times A. That's what you should have, okay? So just give me a second. I'm just gonna color code everything so you can clearly see where we're gonna put each value. Okay, and then of course, C, okay? Now, let's plug in these values. Okay, negative B. If positive B is 7, then that means that negative B is negative 7. Once again, if positive B is 7, then negative B is negative 7. Plus or minus the square root of positive B, which we already know that positive B is 7. 7 to the 7 squared, or 7 to the second power, minus 4 times A times C, okay? A is 2, C is 3. All over 2 times A, and once again, A is 2, so we're just gonna plug in 2 as A. So once you have it in this form, guys, we have plugged in our values in the quadratic formula, and we are actually almost done, okay? So let's just keep going. All we gotta do is simplify. It's pretty easy. Everything outside of the square root sign stays the same, okay? Other than 2 times 2 equals 4, but just stays the same. So I have a negative 7 plus or minus the square root of, okay? Now, 7 squared is not saying 7 times 2. It's saying 7 times 7, okay? It does not say 7 times 2. That's a big misconception in middle school and for some high schoolers as well, okay? So 7 squared is 49, okay? Negative 4 times 2 is a negative 8, and then negative 8 times 3 is a negative 24, okay? So minus 24. All over 2 times 2, which is 4. We are actually almost done. All we gotta do is continue to simplify. Just a couple more steps and we'll be done, okay? So now the only thing that we need to simplify is everything that's inside the square root sign. So once again, everything on the outside stays the same. I still have a negative 7, everything over 4, right? And then the square root, 49 minus 25 equals 24. 49 minus 24, my bad. 49 minus 24 equals 25. Once again, 49 minus 24 equals 25, okay? Now, all we need to do is just figure out what is the square root of 25. Remember, the square root, right, of a number is a number that if it was multiplied by itself, it will equal that number. If I did 5 times 5, 5 times 5 equals 25. So that means that the square root of 25 is 5, right? So this actually goes to 5, okay? So now we're down to the last and final step. We have a negative 7 plus or minus a positive 5 all over 4, okay? Now, the reason why there's a plus and minus sign as an operation, as two different operations, is because we're gonna do both at the same time. We're gonna do negative 7 plus 5 divided by 4, and then the other operation, we're gonna do negative 7 minus 5 divided by 4, okay? So now let's do that. So I'm just gonna pull it up here. I know I'm kind of everywhere now. All right, so now we're gonna do -7 plus 5, and then we're gonna do -7 minus 5, all divided by 4. So -7, -7, 4, 4, and then 5, 5. We're almost done. And then these are the last possible values that x can be, right? If we plugged in those values, and all of this will equal 0, okay? All right, so x equals. Okay, so -7 plus 5 is a -2, and -2 over 4, right? -2 over 4 equals a -1/2, okay? So the third possible value that will work will be a -1/2, okay? Once again, a -7 plus 5 is a -2, -2 over 4, you can simplify that to -1/2, all right? And then now, the last but not least, we have a -7 minus 5. Whenever you have two negative integers or negative whole numbers, just add them up like positives and keep the negative sign, right? So a -7 minus 5 is a -12, and then a -12 divided by 4 is a -3. Okay? So what we have done, ladies and gentlemen, we have figured out the 4 values of x that we can plug in order to make all of this equal 0. So any of these values, right? If I can plug in 4, I can plug in -4, I can plug in -1/2, I can plug in -3. I can plug any of these values as x, and then all of this will equal 0. Okay? So this is how you can simplify fourth-degree polynomials by using the synthetic division method. And then once you get down to a second-degree polynomial, either you can continue to do the synthetic division, or you can actually switch over to a quadratic formula. And of course, the quadratic formula is this right here, okay? So once again, this is the first example of factoring a fourth-degree polynomial. I will come out with at least about 20 more examples in the next few months. So please stay tuned, and thank you for tuning in today.